Hello, this is Taha here with you from CAD MicroSolutions, and today we'll be taking a look at a new PCB design software called SolidWorks PCB. Now, SolidWorks PCB was initially called PCB Works, and it was a software solution offered by Altium. But based on the collaboration between the two software companies, SolidWorks PCB has been added to the line of products of SolidWorks. As you can see from the screen, SolidWorks PCB is powered by Altium, which means that the majority of the functionality, features, and tools that are available through Altium Designer is also available through SolidWorks PCB. And this is really beneficial considering that Altium is a leading provider of PCB design software. In terms of an overview for today's presentation, we'll go ahead and create a new project and go through the various stages of that process. We'll take a look at the schematic environment, the PCB design environment, and we'll also take a look at the collaboration tool that is offered with SolidWorks PCB between the MCAD and the ECAD. And finally, we'll end things off with a little overview of the project management tool that is offered with SolidWorks PCB. So let's get started. We'll go ahead and create a new project. Now, SolidWorks PCB does force you to make your projects into managed projects. And what this means is that your projects are not only stored locally, but they're also stored on a repository. And this gives you access to a little bit of project management features that we'll take a look at up ahead. But it also gives you version control features onto your project. And this is really beneficial. So we'll go ahead and create a blank PCB project, and we'll call it demo PCB. And as you can see, the repository has been chosen to be the default repository, and this is the location in your local machine. And I can even add repository folders and configure them. Okay, so we created a new project. Let's add a new schematic to this project. Alright, now as you can see, and if you have used Altium before, it's a very similar environment with the exception of these ribbons at the top over here. Now this is inherently a SolidWorks feature, this ribbon-based system, and what it allows for is ease of access to these features as well as ease of learning of how to use these features. So if you ever thought that Altium was an easy PCB design software to learn and pick up, well, SolidWorks PCB seems even a lot easier, just with the help of these tabs and this ribbon-based system. They're all organized based on specific tabs, as you can see in the home. So we'll just quickly take a look at them. So in the home tab, we have majority of our features. View tab, we can access the panels. Project, the tab will have features related to the project and options. Tools will have a little bit more features in relation to the environment at hand. And outputs, we can definitely generate our output files, whether it's bill of materials, etc., from this tab. And the ribbons will change based on the environment that we're in. It is a unified platform, which means that we'll be able to create schematic libraries, PCB footprints. We'll be able to create schematic diagrams and PCB files all from within the same software. Let's go ahead and open the libraries panel, and we'll just dock it over here. Now I like to demonstrate the capabilities of the software with a little bit of simple tools. So we will go to header, and let's just get a 6 header pin. We'll get 2 of them. Alright. Now as you can see, I was able to drag the two components apart, creating wires in between it. This is an amazing feature that has been offered through SolidWorks PCB. In terms of placing nets, I could do that easily by going to Home, and we'll go Net. Just edit the properties of this net. We'll start at A1, and as you can see, it increments automatically for me, which is pretty handy. Through the libraries panel, we can access several libraries, whether they have been installed on our machine or libraries that we created ourselves. Now, the software does come with two default libraries, which is the miscellaneous devices and the miscellaneous connectors. Let's go ahead and take a look at the miscellaneous devices, and let's say I want to add a resistor. We'll just add, any resistor here. And again, as mentioned, with the drag capability that has been featured in the software, it's very easy to place components and drag and create wiring just based on that drag feature. All right. We can also place ports, and let's just place one port over here. And what I want to do with that port is I want to display the multi-sheet capabilities of the software, because that is another feature of it. We'll go ahead and save our schematic sheet and save the project. Now, as you can see, you do see that plus sign, and this is relevant to the version control system embedded in the software. So it's telling us that it has been added to version control, but it's scheduled for addition. So let's just add um, that new schematic document. We will save the project. Oh, sorry, save the sheet first. And we will go ahead and commit the entire project, which then will automatically add our remaining files into version control. So let's just add a general comment first, commit. Alright, and now you can see that they all have green check marks next to them, meaning that they're up to date with the repo's version. Okay, as mentioned, we do have multi-sheet capabilities within SolidWorks PCB. So we'll go ahead and create that. As you can see, it comes with the sheet entries, which is the port that I used. And we'll go ahead and save. Gives me an exclamation mark telling me that it has been modified and it's not up to date with the current repo. So we will just commit the entire project. Added top sheet. All right, let's go ahead and recompile this. And the same error system that was inherent in Altium is also available through SolidWorks PCB. This system was very powerful and was able to catch a lot of errors from either within the schematics environment as well as the PCB environment. And we'll take a look at that, the PCB design environment later. So here we have a couple of errors in relation to duplicate components. When clicking on the arrows, it'll take me directly towards the source. And as you can see, I do have duplicate designators for these components. I didn't even annotate them. So let's go ahead and do that. We'll go to Tools, Annotate Schematics, and we'll update the changes list, which will give us a new proposed list of the designator names, and then we'll create an ECO. All right, let's go ahead and save the project. Now, as you can see, when I compiled my project, it did create this hierarchical structure for me, where we have sheet 2 as the top sheet and sheet 1 as the low-level sheet below it. Let's go ahead and commit the project once more, and we can recompile and find out that it compiled successfully. Let's take a look at the errors and the warnings available through the software. Go to project options, and from here we can see all the error reporting violations that are available just from the schematics environment. These errors and violations have been organized based on the object that they deal with. So we have violations with buses, components, nets, etc. And we can configure these violations to be either warnings, no report errors, or fatal errors. We also have the connection matrix, which gives us an overview of what is allowed to be connected. So as an example, an output pin, if an output pin was connected to another output pin, that would cause us an error, and we could tell the compiler what type of error we would like to have, whether it's a no report warning error or fatal error, by just clicking on the block. All right. Let's take a look at a bit of the version control capabilities of the software. Now, as you can see, I've been editing my schematics and committing them and committing the entire project. How can I revert to previous versions? How can I see my changes? Let's take a look at that. So we'll go to the View toolbar and we'll go to Storage Manager. And the Storage Manager allows us to see all the revisions that we've essentially committed through our project. So in terms of changes made to sheet 1, we can see that there have been 2 commits. And right-clicking on a certain revision, we could revert to that revision. And selecting 2 revisions, we could go ahead and compare. And here will tell us the differences generated. It'll split the screen for us, telling us essentially an overview of both of these revisions. And it'll tell us exactly what has changed. So essentially the differences between these 2 revisions is that I annotated one and did not annotate the other. So let's just merge all here. We'll close all documents. Alright, open the sheet again. We'll close differences. Now that we've completed our schematic, let's go ahead and move it to the PCB. Let's add our PCB document. Alright, now let's save it. Yep, there we go. Let's just close the messages, close the storage manager. There we go. And now let's go to Home, Project, and we will import changes. It'll give us here an engineering change order telling us exactly what is about to be brought into the PCB. Validate those changes and execute them. And again, we could here create a report for these changes. Now, before we go ahead and place these components on our board, let's configure the board shape. And here we could go ahead and get into the collaboration side between the MCAD and the ECAD and check out this really awesome tool from SolidWorks PCB. Let's go to View, SolidWorks PCB Connector, and this opens up the panel. And what we're going to do is we're going to push our board onto the server and into the mechanical designer side. So we'll write a message here and we'll say configure board shape, and we'll just post. Alright, now we have pushed that onto the SolidWorks side. Let's go ahead and open our SolidWorks. Okay, so now we have SolidWorks open. We also downloaded the Altium Designer collaboration plugin. So let's just go ahead and pull the board. We'll select our project. Now it's asking us to save our assembly somewhere. So just put it into test demo. We'll save and we'll replace. Alright, it's pulling in design. Okay, so now we have our board. And I would like to design the shape based on another component. So what I'm going to do is I'm going to make an assembly from this assembly. Alright, pulled in our board, and I'm going to insert the component. Let's browse for that. It should be in desktop. Here we go. Okay, first thing I'm going to do is I'm going to mate this face to the bottom side. There we go. And now I'll edit the board sketch. So let's go ahead and edit this sketch. We'll save. And let's just save it in the desktop. Alright. Now I'll just select this face and go ahead and convert to entities. And let's just select the original outline and delete it. Select the new one. Alright. And here you have it. We have the new board shape based on the stepper motor. I can save this assembly now. Save all, and I'll go ahead and open my original assembly. Yep, I'd like to rebuild it. Let's go ahead and push this back into the SolidWorks PCB side. So we'll go ahead and write board shape ready. Post. Okay, and let's move on to the SolidWorks PCB side. It says that it has detected changes to the project. Let's go ahead and view those changes. And it tells us the object is within the board outline. We can see that preview of what exactly has been changed. So we'll go ahead and accept that. And there you have it. It updated the new board shape. So this is really a marvelous tool that you could use between your mechanical designers and your electrical designers, and it will save a lot of time. Okay, let's go ahead and import changes. Alright. Before we begin routing the board, let's go ahead and check the design rules. And here we have a very comprehensive list of design rules to not only allow us to catch violations when needed to, but also give us the flexibility of design. We have electrical design rules, routing, SMT, mask, plane, test point, manufacturing, and placement. And within these categories, there are individual rules, such as clearance rules within the electrical subset, short circuit, unrouted, etc. Let's go ahead and edit the width rule for the full query of all the components. We'll go ahead and change that to 15, 20 we'll leave it as such, and 25. We'll also create a new rule, and we'll call this power width. And from this case, we'll make this one just an exaggerated figure. And we'll make it apply to a specific net. So let's choose A6 as the net. Alright, we can also configure VS sizes. For now, it seems configured as is. So we'll just go ahead and click apply. Okay. Next, I like to configure my layers. So let's click the layer stack manager. With the layer stack manager, we could add signal layers. We could add internal planes. We could change our layer names. So mid signal. We could choose the material, the thickness. We can configure everything in relation with the layers. There are already presets available, and so I like to go to them. And I'd like a 4-layer board. Alright. So here we have a 4-layer board with 2 signal sides and 2 planes on the inside. Okay. Let's go ahead and move these components around. We organize them a bit. Also, if you notice that the layers did update, so we have the component side layer, ground plane, power plane, solder side, and then the other mechanical layers and such. Let's go to the component side and let's begin routing our board. We'll select the route button and we'll select a pad, and right away we'll see a preview of the route. One of the advantages of SolidWorks PCB is to be able to use a lot of shortcuts in the PCB design phase. So to view the shortcuts within the routing mode, we can click on the tilde key. And while in this mode of routing, we can take a look at the next shortcuts that we could use. So one of my favorite shortcuts, and one that I often use, is changing the corner modes. So by clicking Shift and Space, I can change the corner modes of my route. Let's just use the 45-degree one. Alright. We can also select multiple pads and use a multi-route feature, which is called interactive multi-routing. So let's select that, and we have different modes of routing. In this instance, we can ignore obstacle, push obstacles, hug and push. By choosing the push obstacle, I can push my current route away, as you can see. By pressing the plus key on our keyboard, we can also move into the next layer, and that will automatically create a via for us, or vias in this case, and move into the next layer, as you see. We can also change the spacing between the routes by clicking B on our keyboards. Right now I'm just reducing that space. Alright. One of the most useful features that I like to use is to be able to auto route a single route. To do that, let's again use the route button, and by selecting the initial route point and holding control, we can automatically route that one connection. Finally, we have just one more connection left. So let's hold control and select the initial point, and I'll route it. Now, you'll notice something is different about this specific route with net A6, and that is the width of this route is a lot thicker than the other ones. And the reason why this is because we configure that in our rule, in our power width rule. We configured that A6 being a power net will have a thicker width. Another great feature that comes embedded with the SolidWorks PCB design environment is to be able to view our design violations while designing our board. So let's go ahead and demonstrate this right now by rerouting my board and that particular net and going over the other nets. I'll get a green overlay color over the route, and this essentially tells me that there are multiple violations associated with this particular route. So by right-clicking on this route and going to violations, I can see that there are short circuit violations as well as clearance constraints. Okay, let's go ahead and unroute that connection. Now that we've completed routing our board, we might want to view it in 3D. So let's go ahead and click 3 on the keyboard, and right away we can see the board in 3D view. I could rotate my board in any form or spin it in a certain axis. I can also click on certain preset view configurations on my keyboard. And I can flip the board by going to View, Flip Board. By clicking L in this view configuration, I can configure colors in relation to this view. So let's say I want to change my top solder mask and make it, let's say, blue. Okay, apply. Here we go. To go back to 2D view, all I have to press is 2, and it'll take me to where I left off. To be able to change the colors in this view, again, all that is required is clicking L. From this options, we can configure the layer colors for the top layer, the bottom layer, all the mechanical layers, violation markers, etc. Let's take a look at a unique tool that we can use within the PCB environment. Now let's say I have a lot of components on my board and I would like to switch back and forth between my schematic side to view these components and my PCB side. One great tool to use is cross probing. So what I'm going to do is I'm going to split my PCB file and my schematic side file vertically, and so I can see both of them. And in my PCB, I'm going to go to Tools, Cross Probe, and select one of my components, and it'll take me to the schematic side and point to where that was. And in my schematic side, I can also go to Tools, Cross Probe, and let's not select the same one. Let's select, for example, R1. We'll go to Cross Probe, and it'll take me to R1 on my PCB side. So this is a very useful tool for designs with a lot of components. Let's just merge all for now and go back to the PCB design mode. Another great tool that I could use in organizing my PCB is to be able to change colors or overlays of my routes. So if I wanted to configure some nets with a specific color, I could do that. So let's go to View and go to my PCB nets. We'll select all nets. And let's say in this case, I wanted to select my A1 net and make that a specific color for organization purposes. I can go to Change Net Color and select yellow. And then I'll click Check to activate it. And from afar, I can see that I configured this specific net to be yellow, but when we're zooming in close, I could see that it blends with the blue, and I can see exactly what my layer color is and what the net color that I embedded over it is as well. Last step that we need to do is to run the DRC. So to do that, we'll go to DRC, Design Rule Check, and we'll run the check, and it gives us a message, solder mask clearance constraint. Select the solder mask. Let's go into the PCB, and another great feature that we could use within SolidWorks PCB is to zoom in onto the rules and violations that have occurred. To do that, let's go to View, and we'll go to Rules and Violations. We'll just fix that panel right here. In this panel, we have all the rules that we configured. And within these rules, we can also find the violations. So let's just go ahead and go to All Rules. And it says there are 2 violations. Notice that by clicking on the violations, it zooms in exactly where it is. And it tells me, oh, there's an overlay clearance constraint here. By double clicking on it, I can even highlight exactly what the error, the source of the error is. Now, within this panel, I can also configure the design rules associated with the violation. So select the solder mask clear. I can double click on that rule and change my minimum clearance. Let's make it 5. And now let's run our design rule check once more. And you'll notice that we get no errors or violations. Finally, generating outputs. By going to the Output tab, we can generate our outputs individually, whether it's the Gerber files, Gerber X2, ODB++, NC files, or we could generate all of this automatically or as a bundle of output files, and this can be done from the Projects toolbar. Go to Generate Outputs, and automatically I can generate multiple output files at once. And I can configure their options as well. I did mention before that SolidWorks PCB does come with a bit of project management options. It's important to note that it does come with a browser-based project management solution. So let's take a look at that. And now I'll just sign in with my credentials. So there are several tabs here to explore. In the Home tab, we can see recent activity that has been done on our projects. So there are several tabs here to explore. In the Home tab, we can see recent activity in regards to our projects. In the Users tab, we can configure new users in our organization and configure specific roles for them, whether they're administrators, mechanical designers, electrical designers, or procurement, for example. In our Projects tab, we can explore the different projects that we have stored in our repository. We could open them, edit them, share them with specific users, as well as remove them from the repository. By going to VCS, we could configure and add new repositories into our project management solution. And finally, in the Stream tab, we'll be able to receive notifications and messages in relation to our projects. And this again could be important for project managers to be able to see new commits that have been added to the project, whether the project has been created or not, and such. Before we wrap things up, I'd like to go through a more complicated project to demonstrate the capabilities of the software. Here we have the Bluetooth Sentinel project. Going to the PCB document, we can see that there are a lot more components on this board and a lot more layers. We have 4 signal layers and more mechanical layers. Taking a look at this board in 3D, we can see that the overall board shape is a little bit more complicated. Let's demonstrate a little bit more of the SolidWorks connector capabilities. I'd like to push this to my mechanical designer. Okay, so here we go. We have our board loaded with all the components and their individual models. So let's say the mechanical designer receives this and says, I would like you to move this component a little bit over here, and that one, let's just float it, and that one over here, and this one over here. Okay, and now let's push this back into the Altium side. Moved components around. Let's post that. Alright, push successfully. Let's go ahead and go to SolidWorks PCB. And like the last time, it detected new changes. Let's view those changes. Okay, so it tells us a preview of exactly what happens. The placement change. Let's click on the preview, and it's really cool to see these to see the placement, a preview of the placement of these components change. Right, so you don't have to accept the changes and then realize that you didn't want them. You could preview them to see if that is exactly what you want. Let's just say I would like to have all these. Let's accept the changes, re-pour our polygon. And as you can see, our components did move. Obviously, there are errors in terms of clearance constraints between the bodies, but this is just an excellent demonstration of the SolidWorks PCB connector. And this really concludes our presentation. I hope you found it beneficial. This is a really exciting tool, one that I feel will get a lot of attention, especially with the ability to use the collaboration between the mechanical designer and the electrical designer. Thank you, and hope you enjoyed it.